Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from May June 2023, Paper 1, Variant 1. In today's lesson, we will talk about questions from waves, electricity, and radioactivity. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics and also you can have better understanding of these questions. Let's study together, let's improve together. Question 21 says the graph shows the variation with time of the displacement of a particle in a progressive wave. Two measurements x and y are labeled on the graph. What do x and y represent? So we have displacement on y-axis and we have time on x-axis. So it means x is the maximum displacement. So x is representing amplitude because this is the maximum displacement of particle, amplitude. And this is the time period. So this is time period for one complete cycle. So for one complete cycle, time taken is time period. So this is one complete cycle. So this time is time period. So the answer for this question has to be A. Question 22 says a car travels at a constant speed along a straight line PQ. A loudspeaker attached to the car emits sound of constant frequency F. A stationary observer is at point O. What does the observer hear as the car moves from P towards Q? So first thing in this case we need to understand the source is approaching observer. So this source is approaching observer. It means there is relative motion between source and observer. As there is relative motion, it means there is Doppler effect. So there is Doppler effect. Doppler effect. As the source is approaching, it also means that observed frequency, this has to be greater than frequency of the sound produced by source. And also we can look at this point. When the source is at this point, there is no relative motion between source and observer because the source is not approaching observer and the source is not moving away from observer. So at this point, observed frequency, this one has to be equal to frequency of sound produced by source because there is no relative motion at this point when the source is at this point. Now let's try to answer this question step by step. First of all, we will assume this angle is theta naught. Then this speed is v, mean this velocity is v. So we can resolve this velocity into two components. We can resolve into one component. This one we can say this component is Vx and perpendicular component, this one at an angle of 90 degree, angle between Vx and Vy, let's say this is Vy, angle has to be 90 degrees. So this angle is 90 degrees. So in this case, due to Vx, there is a relative motion between source and observer, so we can write down Doppler effect formula. F observed, this has to be equal to the speed of the wave divided by speed of the wave minus the speed of the source, component of speed of the source that causes relative motion, means that component is Vx. So very important one, not only the speed of the source, you have to take component of the speed of the source that causes relative motion. So in this case, the relative motion between source and observer is due to Vx. So this component has to be Vx multiplied by frequency of the source. So we can rewrite this formula. We can write down this is speed of the wave and this is divided by speed of the wave in the medium minus this is Vx. So this is V cosine of theta, V cosine of theta, because Vx is equal to V cosine theta multiplied by frequency of sound produced by source. Now we need to understand how this theta is changing when the source is approaching observer. So for that purpose, we can imagine when the source is at this point, we can imagine when the source is at this point, we can imagine when the source is at this point. So first of all, when the source is here, so we can draw this line, we can give certain name to this angle, and we can also draw an other line when the source is at this point and when the source is at this point. Let's say this angle is theta 1, this angle is theta 2, and this angle is theta 3. So in this case you can simply see theta naught, this is smaller than theta 1, and this is smaller than theta 2, and this is smaller than theta 3. So it simply means that when we are moving from point P to point Q, theta is increasing. As theta is increasing, so how about V cosine of theta? V cosine of theta. So first of all, we have to look at cosine theta. If angle increases, cosine of theta decreases. Let me write down in a little bit different way. So if theta increase, cosine of theta, this decreases. As cosine of theta decreases, it means that V cosine of theta, we can rewrite here. So V cosine of theta decreases. So these are the points you need to understand. And if you have understanding of these things, now we can go back to Doppler effect equation. So if you look at this, if this one decrease, how about overall this one? Overall this one will increase. So overall this one will increase. If overall this one increase, how about this frequency? Observed frequency will decrease. This is the main point you need to understand. So it simply means that at this point, observed frequency, this one is maximum. So let me use different color. Let me use red one because this point is very important. So at this point, observed frequency is maximum, and at this point, observed frequency, this is minimum. I mean, this is equal to frequency of sound produced by source. I hope that now you can see why these two frequencies are equal at this point. Let me explain you why they are equal at this point. So we can rewrite this formula. So we can say f naught, this is equal to speed of the wave divided by speed of the wave, means speed of the sound in the medium, minus component of speed of the source that causes relative motion. So that is V cosine of theta, multiply by frequency of sound produced by source. So in this case, now simply you can see this angle is 90. So what is cosine of 90 degrees? Cosine of 90 is equal to 0. So it means this term, this is equal to 0. Now you can see from here that f naught, this is simply equal to V, speed of the sound, divided by speed of the sound, multiplied by f. So in this case they are cancelled. So we got f naught equal to f, a beautiful point. This is simply telling us if there is no relative motion between source and observer, there is no Doppler effect. Now let's try to summarize what we have discussed about Doppler effect. So for Doppler effect, we have discussed one very important point for this question, that f observed is always greater than f. When the source moves from this point to this point, f observed is greater than frequency of the sound produced by source. So this is one point. So you need this point to answer this question. And the second thing we have discussed, when the source moves from point P to point Q, observed frequency is decreasing, because here frequency is maximum, observed frequency is maximum, and here it is minimum. So this observed frequency is decreasing when the source moves from P to Q. So these 2 points you need to find the best possible answer, or simply we can say best possible option for this question. So if you look at option A, a frequency less than f, this is not possible. Frequency less than f, not possible. A frequency more than f, yes, that decreases as the car moves from P towards Q. So this one is our answer. A frequency more than f, yes, this is right. That increases? No, that decreases. So the answer is C. We have discussed a lot of points about Doppler effect. If you only understand this question, it means any question about Doppler effect, simply you can answer. Question 23 says some sources of electromagnetic waves in free space are listed. Which list gives the sources in order of increasing wavelength from left to right of the waves emitted by the sources? For this purpose, simply we need to understand electromagnetic spectrum, order of EM waves in electromagnetic spectrum. One way to remember electromagnetic spectrum order is simply you can remember Granny's X box use volts in my room. So this is one way to remember the order. So in this case we have here G, this is for gamma, so these are gamma radiations, X for X-rays, and U for UV light, and V for visible light. And visible light consists of 7 colors, and I for infrared, so we can write down this order, and M for microwaves, and R for radio waves. So we have to start with the smallest one. So one thing we need to understand, in this case, if we move from gamma to X-rays, means gamma to radio waves, mean if we go in along this line, wavelength is increasing, so the lambda in this case increasing. So lambda is increasing, energy is decreasing, lambda is increasing, so we can say energy of photon this decreases, and frequency also decreases. So very important one you need to understand. So we have to start from the smallest one. In this list we don't have gamma, so it means the first one has to be X-rays. So this is X-rays. And the second one, we don't have UV, we have visible light. So the second one, we have visible light. So this one has to be the second one, visible light. And after visible light, this is 30 millimeter radar transmitter, because radio waves, the lambda is greater than 1 meter. So the lambda of radio waves, this is greater than 1 meter, and so on. So it means this one has to be the third one, and this one has to be the fourth one. So the first one, the number is 2, so it has to be 2. So the answer can be B, or answer can be C. And the second one has to be 4. So it means second one has to be 4. So this is right, this is right, this is right, this is right. And the third one has to be number 3, means this one, but this is telling you 1, so this is wrong, this one is right, so this is also right. So the answer for this question is C. Simply you need to understand order of electromagnetic waves in EM spectrum. Question 24 says a vertically polarized beam of light is incident normally on a polarizing filter. The transmission axis of the filter is at an angle of 40 degrees to the horizontal, and we need to find out the ratio between amplitude of transmitted beam and amplitude of incident beam. So simply in this case, the first thing you need to understand is that incident light is vertically polarized. So we can draw this vertical arrow to represent incident light is vertically polarized. And the second thing we can do is we can also draw the vertical line here. So this is representing vertical axis. And we can also assume in this case, let's say the intensity of incident light is I naught, and intensity of transmitted light, this is IT. Now we need to use Males's law. Males's law simply tells us how transmitted intensity and incident intensity, they are linked with each other. So IT is equal to I naught times cosine square of theta, and theta is the angle between incident light. Very important one. This is the point you need to understand. Angle between incident light and transmission axis. So we can say transmission axis. So this is the main point. So in this case, angle between incident light, so this is incident light because this is vertical, and this is our transmission axis. So this one is transmission axis. So angle between these two, this angle is 50 degrees. So simply we can write on here it is equal to I naught cosine square of 50 degrees. So if we solve this one, we will get it, this is equal to I naught times 0.41. So we can also write down it over I naught, this is equal to 0.41. Now this is not the final answer. We need to find the ratio between amplitude of transmitted beam it over A naught. So we can say amplitude of incident light is A naught, amplitude of transmitted light is AT. We have to find ratio between AT over A naught. But we understand that IT, this is equal to K times AT square, and I naught, this is equal to K times A naught square. So now we can divide these two. So let's say this is equation 1, this is 2. So in this case we have it, that is divided by I naught, and here we have this is AT square divided by A naught square. K will be simply cancelled, and this one we have already calculated, it over I naught, this is equal to 0.41. That we need to find out AT. So we need to find out AT over A naught. So we have to take square root on both sides. So this is 0.41. So we have to take square root of this one. If we take square root of this, we will get 0.64. So we will get 0.64. So our answer for this question is C. So this is how you need to answer. So let me highlight the points you need to understand for this question. This is one important point, the angle. You need to understand which angle you have to take when you use Malice's law. And the second thing you need to understand, how IT and AT, they are linked with each other. So if you understand these points, simply you can find the answer. Question 25 says two progressive waves meet at a point. Which condition must be met for superposition of the waves to occur? The waves must be coherent. Coherent means that waves have constant phase difference and waves have same frequency. This is not requirement. This is not condition for waves to interfere with each other, to superpose with each other when they meet at a point. So this is not the requirement. The waves must be of the same type. Yes, because sound waves, they cannot interfere with electromagnetic waves. Electromagnetic waves, they can interfere with electromagnetic waves. And two types of sound waves, mean one has high frequency, one has low frequency. They can superpose, they can interfere with each other at a point. So this condition need to be fulfilled. So the answer for this question should be B. The waves must be traveling in opposite direction. No, they can be traveling in the same direction. So this is not condition for superposition of the waves. The waves must meet in phase. This is also not requirement. They can be in antiphase. There can be any phase difference between them for them to superpose. So this is also not requirement. So the answer for this question is B. Only same type of waves, they can interfere with each other. Question 26 says a string is stretched between a vibration generator and a fixed point. When the vibration generator is vibrating at a frequency f, a stationary wave with 5 nodes is created on the stretched string as shown in the figure. There is a node at the end of the string that is attached to the vibration generator. Means we have node at this point. The frequency of vibration of the vibration generator is slowly increased. The frequency of vibration is slowly increased. What is the next frequency that produces a stationary wave on the string? So this is a typical type of question about stationary waves. So let's try to understand how we can approach. First thing we need to understand, when we will increase the frequency, when we increase frequency, lambda of the wave will decrease, but speed of wave will not change. Very important point. Speed of the wave will not change, because speed of the wave, it depends on the medium and it also depends on type of wave. So speed depends on type of wave. So this is the point you need to understand. It depends on type of wave, and speed of wave depends on medium. So as in this case, type of wave is the same and medium is the same, so it means speed is the same. So if we increase frequency, lambda will decrease. And also we need to understand lambda is, so the distance between two consecutive notes, this is equal to lambda by 2. So in this case, how many loops we have? We have 1 loop, 2, 3 and 4 loops. So for this one we can find the lambda. Let's say the length of this string, length of string will remain same. So we have length of string that is equal to L. So in this case, L is equal to 4 times lambda by 2, or we can say this is equal to 2 times lambda. So from here we can write down lambda is equal to L by 2. So this is over 1 lambda. We can say this is lambda naught, or it's better we can say this is lambda 1. So very important point, we will discuss some beautiful points here. So we can say this is lambda 1. Now how about the next stationary wave? Next stationary wave will form when it has 5 loops. So let me show you how the wave will look like. So this is how wave will look like. Now we have 5 loops. You can draw this one by yourself. So we have 5 loops here. So this is 1 loop, second one, third one, fourth one, and this is 5th one. So in this case, this is also lambda by 2, but this lambda is different. Now we can write on here, in this case L is equal to 5 times lambda 2 by 2, because this lambda is different now. Very important, lambda has changed. So this is what this was lambda 1, so this is lambda 1, so this is lambda 2. So lambda 2 from here we can write down, this one will be equal to 2 times L divided by 5. So this is lambda 2. But we have already discussed that in this case speed is constant. So we can say V1, this is equal to V2. So we have here lambda 1. We have F1 that is equal to F. This has to be equal to lambda 2 times F2. So F2 we need to find out. So we can say in this case F2 will be equal to lambda 1, so we can write down lambda 1 times F divided by lambda 2. So we have lambda 1 that is equal to L by 2, so we can write down this is equal to L by 2 times F divided by, this is 2L by 5, or we can say we have here LF by 2 multiplied by, we have 5 divided by, we have 2L. So in this case we can cancel this L with this L, so we left with, we can write on here, so F2 this is equal to 5 divided by 4 times F, so this is equal to 1.25 times F. A beautiful question and a beautiful technique to handle this type of problems. So our final answer is 1.25. So the answer for this question is A. So very important technique, speed remains constant. Then simply you need to figure out lambda 1, you need to figure out lambda 2, and speed is the same. Equate these two and you will find the answer. A beautiful question. Look at this question again and try to master this approach. Question 27 says a ripple tank and a barrier with a single gap are used to demonstrate the diffraction of surface ripples on water. Initially, the wavelength of the ripples is 5 times smaller than the gap in the barrier, which change increases the amount of diffraction observed. So we need to understand significant diffraction is observed when lambda is about equal to the gap size. And if we want to increase the diffraction, we have two options. We can increase the lambda or we can make the gap smaller. In this case, diffraction will increase. So we can say diffraction will increase, amount of diffraction increase. So in this case it is given to us lambda is smaller than, so lambda is smaller than gap. So if we want to increase diffraction, we have to increase this lambda or we need to decrease the gap. Double the amplitude of the ripples, it has no effect. Double the width of the gap, this will decrease diffraction. Halve the frequency of the ripples, it means increase the lambda, so this will increase diffraction. Halve the wavelength of the ripples, this will decrease diffraction. So then so far this question is C, a typical question. So this is the concept you need to understand. If we want to increase diffraction, we have to increase lambda and we need to decrease the gap size. So halve the frequency means lambda is double because speed of wave in the same medium remains the same. So the answer for this question is C. Question 28 says a laser produces a beam of light of wavelength 650 nanometers. The beam is incident normally on two slits that are a distance of 0.12 millimeters apart. A screen is placed parallel to the slits. The bright interference fringes on the screen have a separation of 7.5 centimeters. What is the distance between the screen and the two slits? So first of all, simply we can draw over double slit. So this question is simply about double slit. So here we have the screen. So in this case, the distance between these two slits is given. We can say this distance is A. So here we have the bright fringe. So this is the bright fringe. Then we have the first order bright fringe, second order bright fringe, and also here we have first order and we have second order. We also need to understand in this case the distance between two bright fringes, between any two bright fringes. So let's say this one, between any two bright fringes is X. And we can say the distance between screen and the slits, this distance is D. So this one is over screen. We have to find out in this case D. For double slit we need to understand AX, this is equal to lambda times D. So D we need to find out. So this has to be equal to AX divided by lambda. And so in this case we have value of A, slits, this value is given to us. So this is our value of A and this one is over X and this is lambda. So we have value of A, that is 0.12 times 10 to minus 3 because this is in millimeters, and we have value of X, that is 7.5 times 10 to minus 2. We have to convert into meters, and here we have 650 nanometers, 10 to minus 9. Now simply we need to solve this one. If we solve this, our final answer will be equal to 14 meters up to 2 SF. A typical question, simply you need to use this formula. That's all, and you need to convert units. So then so far this question is D. Question 29 says a beam of light from a laser is incident normally on a diffraction grating. The diagram shows only the second order maxima that are produced. The grating has a line spacing of 1.0 times 10 to minus 6 meters. The angle between the two second order maxima is 110 degrees. We need to find out what is the wavelength of light? A beautiful question. So it simply means that if you pass light through diffraction grating, you can find out the wavelength of light. A beautiful way to find the wavelength of light. So in this case, we are using diffraction grating. So simply we can imagine our screen is placed here. So this one is the screen. And in this case, we can also draw one line from the center. So it means here we will observe center maxima. Now we need to understand the formula for diffraction grating. D sine theta, this is equal to n times lambda. So in this case, we will have center maxima here, and then we will observe the first order, and then we will observe the second order. So here will be the second order, and here also we will observe the first order, and here we will observe second order. Now for this formula, we need to understand what is this angle. This is the angle between center maxima and the next fringe. So it means we have to take this angle. So this has to be measured from center maxima. So this is the point. You have to measure from center maximum. So from center maximum. So we have to measure from here. So it means that this is half of the given angle. So this is 55 degrees. So that's all what we need to understand. For this question, we need to find out value of lambda. So we can say this is equal to d sine of theta divided by n. So in this case, n is given to us, that is 2, and value of d is given to us here, and angle is also given. So now simply we can plug in values. D in this case is 1.0 times 10 to minus 6, and we have sine of 55 degrees divided by 2. So if we divide this one by 2, we will get our final answer. So in this case, final answer will be equal to 4.1 times 10 to minus 7 meters. So this is value of wavelength. So this is how you can find out. So 4.1 times 10 to minus 7 meters. So the answer for this question is A. Only the key concept you need to understand, from where you have to measure the angle. Angle you have to measure from center maxima, means from this maximum. Question 30 says the electric current in a metal wire is 4.0 milliamps. How many electrons pass a fixed point in the wire in a time of 10 hours? A beautiful question, very nice question. We can simply answer this question, but if you don't have the clear picture of what is happening in this case, so that's not good. That is not physics. That is just using formula. So let's try to picture this one, try to depict this one. So we can draw this wire. So you can imagine this one is the wire, and current in this wire we can say is equal to 4.0 milliamps. Now if we look at one single point in this wire, let's say we look at this point for a time of 10 hours, how many electrons we will see passing through this point, or how many electrons we will count. How we can find the number of electrons we will see, if we can see, passing through this point. So let's try to answer now. So we can start with Q, that is equal to I times T, means the amount of charge passing through this point, and amount of charge will be equal to n times charge on single electron, and this is equal to IT. So for this question we need to calculate n, so we can write down this is IT divided by E, and value of I is given, that is 4.0 milliamps. So this is 10 to minus 3, and time is 10 hours, and 1 hour has 60 minutes, and 1 minute has 60 seconds, and we need to divide this one by the charge on single electron, that is 1.6 times 10 to minus 19. So if we solve this one, we will get 9.0 times 10 to 20 number of electrons passing through this single point. If current is this one and we look at this point for this period of time, we will see this many electrons passing through this point. So try to visualize physics. Physics is beautiful. Physics is your way of thinking. Otherwise it becomes very boring if you just use the formula. Try to enjoy that. Try to develop your way of thinking. Physics is way of thinking. So the answer for this question is C. So C is the answer. Question 31 says, what is the definition of the potential difference across an electrical component? Potential difference simply is equal to the work done per unit charge. Work done per unit charge. So simply we can say work done per unit charge. Or we can say this is the electrical energy transferred into other forms of energy per unit charge. So we can say electrical energy transferred to other forms of energy per unit charge in an electrical component. So if you look at given options, for option B it is given to us the energy transfer per unit charge. So this is the right answer. The charge per unit time, this is current, this is wrong. Force per unit charge, this is electric field, this is also wrong. Resistance per unit current, this is also wrong. So the answer for this question is B. Question 32 says, which graph shows the IV characteristics of a filament lamp? For a filament lamp, we need to understand how PD and current, they are linked with each other. Imagine that first of all we increase PD across filament lamp by this much. Arrow is representing the increase in magnitude of delta V. So increase in delta I, this one will be small. So let's say this is this much. PD and I, they will not increase by the same amount. Now the second thing, let's say we increase PD again by the same amount, and in this case increase in current will be even smaller. Now we again increase PD by the same amount, so increase in current, even we increase more, so increase in current will be even smaller. So this will be getting smaller and smaller. So this is the thing you need to understand about filament lamp. So what this is telling us, this is telling us that R is equal to delta V by delta I. For the same increase in PD, increase in I is getting smaller. It means the resistance of filament lamp increase with increase in PD. So how we can find the resistance? In this case, if you look at the gradient is equal to delta I by delta V. It means this is equal to 1 over resistance. So resistance from here will be equal to 1 over gradient. So as the resistance of filament lamp increases, so the gradient has to decrease. So we have to find a graph where gradient is decreasing. So this is not possible because this is for diode. It is gradient is increasing, this gradient is constant, and this is for metallic conductor, or we can say for ohmic conductor, or we can say for fixed resistor. And for this part we can take 2 points. Let's say we take 1 point here. So if we draw the secant line, and we can take an other point here, so in this case also gradient is increasing. So this is not for filament lamp. And if we look at this graph, we can take 2 points. Let's say we take 1 point here, and we can take an other point here. So these 2 points we can take. So in this case the gradient is decreasing, so it means resistance is increasing. So the answer for this question is D. A beautiful thing you need to understand about filament length, and most of the time students they don't understand this one, or they have misconception about that. So try to master this. So the answer for this one is B. Question says a metal wire has a length of 2.50 meters and cross-sectional area of the wire is 4.50 times 10 to minus 6 meters square. The resistivity of the metal is equal to this. The wire is stretched so that its length increases to this one. The wire remains cylindrical and volume of the wire remains constant. Very important. Volume remains constant. So what is the change in the resistance of the wire? So we need to calculate change in the resistance of the wire. So first of all, we can calculate value of R naught. We can calculate value of R naught in this case. So to calculate that one, simply we need rho L by A. So we can find out value of resistance. Then we can find out value of R nu, and R nu will be equal to rho times L nu times A nu. So we can find out value of R nu, and we need to find change in the resistance, means delta R. This will be simply equal to R nu minus R naught. So this is how we can figure out. So first of all, we have to find out in this case value of A nu. So this is value of L naught, and this is over A naught, and this one is the resistivity, and we have L nu. So simply we need A nu. If we have value of A nu, we can plug in values and we can find the answer. So we can write down this one, delta R, this is equal to rho L nu divided by A nu minus, we have this is rho L naught divided by A naught. From here we can take rho common, so we left with L nu divided by A nu minus we have L naught divided by A naught. We have all the values, only A nu we don't have. In order to find A nu, it is given to us volume remains constant, so it means that A naught volume is constant. So it means A naught L naught, this has to be equal to A nu L nu. So from here we can calculate A nu. So this is equal to A naught L naught divided by L nu. So we have value of A naught, that is 4.50 times 10 to minus 6, and value of L naught we have, that is 2.50, and we have value of L nu, that is 2.65. And if we solve this one, we will get the final value of A nu. So we will get in this case 4.2 times 10 to minus 6 meter square. So this is value of A nu. A nu. So this is A nu. Now simply we need to plug in values. Resistivity is 3.50 times 10 to minus 7. We have L nu, that is 2.65. We have A nu, that is 4.2 times 10 to minus 6, minus we have L nu, that is 2.50 divided by 4.50 times 10 to minus 6. And if we solve this one, we will get our final answer, that is 0.024 ohms. So this is the change in resistance. So this is how you can figure out. There are few points you need to understand. This is the main point you need to understand. Volume remains constant, in also it remains cylindrical. So these are two assumptions. So you can calculate A nu, then simply you need to understand, you need to find the difference. So the answer for this question is B. Question 34 says, which circuit symbol represents a microphone? If you look at option A, this is representing bell, and this is representing buzzer. So this is representing buzzer, and this is representing microphone. So microphone, and this is representing speaker. For this question, we need to find out circuit symbol for microphone. So the answer for this question is C. Question 35 says a battery with internal resistance is connected to a fixed resistor, an ammeter and a voltmeter as shown in the figure. The battery is replaced by a different battery that has the same electromotive force but a greater internal resistance. What happens to the readings on the ammeter and voltmeter? So we can imagine this is R and this is capital R, and EMF of this one is E. So in this case, EMF has to be equal to I times small r plus capital R. So from here we can say I, this is equal to EMF over internal resistance plus resistance of load resistor. As in this case, value of this small r increases, EMF is the same, this is also the same, it means current has to decrease. So the ammeter reading will go down, and this value of V is equal to I times capital R. In this case, load resistor resistance is constant but current decreases, so the voltmeter reading also decreases. So ammeter reading will decrease, voltmeter reading also will decrease. So the answer for this question is A. A typical question also, so you need to understand this equation. Question 36 says 4 potential divider circuits each consist of a battery of electromotive force 9 volts and negligible internal resistance connected to a combination of resistors. Each of the resistors in the circuit has a resistance of X R2X. Which circuit has the largest output voltage V? So for this purpose we can draw one very simple potential divider circuit. So we can imagine we have just 2 resistors, they are connected in series. So this is our very simple potential divider circuit. We can say EMF of this power supply is V0 and it has no internal resistance. We can also assume this resistor is R1 and this one is R2. So if we need to find out the PD across first resistor, let's say V1, so V1 will be equal to R1 divided by R1 plus R2, because same current is passing through them, multiplied by V0. So this is how we can find out. So in this case, if R1 is big, it means V1 will be greater. The same principle we have to use. In this case we have X here, so it means R divided by 2R, so this value will be half of this value, mean the same PD across this one, same PD across this one, so this value will be 4.5 volts. And in this case we have 2X and this is X, so this PD will be divided into 3 parts. We can also use this formula, so we will get in this case V, this one will be equal to 2X divided by X plus 2X, means we will 2X, and this will be multiplied by 9. So in this case we have 2X divided by 3X multiplied by 9, so we will get in this case 6 volts. In a beautiful way, simply you can understand potential will be divided into 3 parts, 2 parts across this one, 1 part across this one, so it means this has to be 6 volts. If we look at the total resistance of these 2 resistors, we can calculate the total resistance. So we can say R in this case, this will be equal to 2X times X divided by, we have 2X plus X. So here we will get, this is 2X square and here we have 3X, so we can cancel 1X with this one, so we left with 2 by 3X, or we can say this is about 0.66X. 0.66X. So the resistance of this one is 0.66X and this is X. So in this case the PD across this one, this will be smaller than 6.0 volts. So this will be smaller than, you can calculate exact value, you can plug the numbers, you can find out, you can use this formula. And for this one, the resistance of this combination resistance of this combination, this also will be equal to 0.66x. And in this case, the value of V, if we calculate, because this is 1x, this is 0.66x, so value of V, if we calculate here, this also will be less than 6.0 volt. So it simply means that we need to find out the largest. So the largest is across B. You can calculate the exact values simply using this formula. Question 37 says a voltmeter is connected into a circuit where the polarity is shown. The sliding contact is moved to end P of the potentiometer and then to end Q. What are the two readings of the voltmeter? We can answer this question using two different methods. We can use potential method. We can also use KVL, Kirchhoff's second law. I have explained this question in October-November 2020 paper 1-2 using potential method, and also this question is a repeated question, same question you will see in October-November 2020 paper 1-2. I have explained in that paper using potential method, and now I will explain you the same question using Kirchhoff's second law. This question using Kirchhoff's second law. According to Kirchhoff's second law, in any complete loop, delta V is equal to 0. This is based on conservation of energy. So in this case, first of all, we will consider when the sliding contact is at end P. So we have to take one complete loop. So this is over complete loop now. So we will start from this point. If we go from positive to negative, in this case potential is decreasing, so the change in potential will be negative. So we will write down 3 volts, so this is negative, plus the reading on the voltmeter, so this is V, it has to be equal to 0. So it means V in this case, this will be equal to 3 volts. Now we have to consider when the sliding contact is at end Q, at this end. So let me draw this one in a proper way. So when this sliding contact is at this point, is at point Q. So in this case, our loop is this now. So we are taking this loop. So this is our complete loop. So in this case, let's start from this point. So we go from positive to negative, potential is decreasing. So the decrease in potential, this will be negative, plus reading on voltmeter, so this is V, and in this case current will flow from positive terminal and current will go this way. So if we go in direction of current, we will lose potential. It means the potential will decrease, so the change in PD, that will be negative. So the potential drop across this resistor is equal to 3 volts. So this is minus 3 volt, and this one has to be equal to 0. So V from here means the reading on voltmeter, we can find out that will be equal to 6 volts. So the answer for this question has to be D. So this one is the answer. A very nice question. You need to understand how to use Kirchhoff's second law for this type of problems. A beautiful approach. I hope this one is clear to you. So you need to understand, if you go from positive terminal of the battery, means if you go this way, so we go from high potential to low potential. So the change in potential, so delta V, it has to be negative. So it means that PD, change in potential will be negative, so the PD will be negative. And if we go this way, delta V will be positive because the potential increase. So the change means the PD. Change means PD, change in potential, that is positive. And if we go in direction of current, let's say we have this resistor. So let me write down here. If we go in direction of current, PD will drop. Potential will drop. So potential will drop when we go in direction of current. It means that PD will be negative, means the change in potential will be negative. PD is change in potential, and vice versa is also true. Let's say we have this resistor and the flow of current is down and we go in this direction, in opposite direction. In this case, potential will increase. So the change in potential means the PD that has to be positive. So what is PD? Change in potential. If potential increase, it means PD is positive. If potential decrease, it means PD is negative, means the change in potential is negative. I hope these points are clear to you. So if you have understanding of these points, you can answer. So the answer for this question is D. And also please check this paper. You can find out another method to answer this question. Question 38 says a proton has mass m sub p and charge plus e. What are the mass and charge of an antiproton? So we need to understand particle and antiparticle, they have the same mass. So first thing we need to understand, particle and antiparticle, they have same mass and they have opposite charge. So this is the point you need to understand to answer this question. Same mass and opposite charge. So the mass has to be same. So answer has to be CRT. And this is the charge on proton. So the charge on antiproton has to be negative. So the answer for this question is D. Particle and antiparticle, they have the same mass and other properties are opposite. It means charge is one other property. So charge also has to be opposite. Question 39 says a uranium nucleus has 92 protons and 143 neutrons. The nucleus emits a total of 3 alpha particles and 4 beta minus particles to form nucleus X. How can nucleus X be represented? So first of all, we have uranium nucleus. It has 92 protons, mean its atomic number is 92, and the mass number is the sum of these two. So we have 92 plus we have 143, so the mass number is 235. So we can write on here 235. It forms nucleus X and it emits 3 alpha particles. So we have 3 alpha particles and it emits 4 beta minus particles. So in this case, atomic number has to be conserved. So we can write on here atomic number of this one. So this is atomic number of this. So it emits 3 alpha particles, mean it will decrease by 6. So this has to be 6 minus, so this is 4, so this has to be 4. So it simply means that atomic number decreases by 2. So this one has to be 90. So it has to be 90. Sum of them has to be equal to this one. So it means this has to be 90. So the answer in this case can be D, or answer can be A. Now we need to look at mass number. So we have 235. So this is the mass number of X. So this is what we need to find out. Plus mass number decreases by 12 and there is no change in mass number because this is 0. So it simply means that 92, we have 235 minus 12. So we will have 3 here, and 5 minus 2 we will get 3, and 3 minus 1 we will get 2. So 223. So this has to be 223. So we can make it little bit bigger and we can write on here, this one has to be 223. So the answer for this question is D. So this is how you can answer. I hope this question is clear to you. Question 40 says, which statement about a proton is correct? Proton consists of 3 quarks. It consists of 2 up quarks and it consists of 1 down quark. So proton is baryon because baryons, they consist of 3 quarks or anti-quarks. And proton is also hadron. So proton is also hadron. So proton is baryon and proton also belongs to hadron family. hadron family because they experience strong nuclear force. So proton is baryon, and proton also belongs to hadron family because protons experience strong nuclear force. Leptons, they do not experience strong nuclear force. So if you have understanding of this one, you can find the answer. A proton is a baryon. Yes, this is right. Not a meson. Yes, this is also correct. So the answer for this question is A. A proton is a meson. No, this is not correct. But not hadron. This is also incorrect. It is a hadron. A proton is both a hadron and a meson. No, it's not a meson. A proton is both a meson and a baryon. No, it is baryon. Particle can be baryon or particle can be meson, because meson, they consist of quark and antiquark. Baryon, they consist of 3 quarks or 3 antiquarks. And that's all for today's video. So the answer for this question is A. I hope this video was helpful. If this video was helpful, please like and subscribe. And if you need more help, you can also join Patreon. The link for Patreon is in the description. And if you have any questions, please leave your questions in comments and I will try to answer as soon as possible. See you in next video.